Testing, testing. 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 Testing, testing.
A bit more. Are absolutely amazing. Not digital. Gee, I tell you what. Sorry?
This is your desk.
Is what?
Your desktop.
Yes, yeah, that's my desktop. That's my.
You see my Henry distillery.
Oh yeah. Oh, I went down there with Steve. We did a.
Yeah, we've been there a few times.
Actually, where is Steve? Oh, that's funny.
We've been there a few times.
Yeah. Well, we had to train up all these tour guides. I felt sorry That was a well-timed comment. Are we going to start? Oh, no. Oh, that'll do us. Music. Oh, sorry, I always do this. You know how I always have music. It's quiet though. No. Okay, so I decided to, for this talk, to kind of blend June, July, August, all that sort of stuff together, just to look at the main things in the night sky. Yeah, while we're outside. So looking north, now I've pitched this at August the 15th. So, you know, it's late-ish winter, for want of a better way of putting it. And just looking north, a couple of interesting things there. Can anyone tell me what constellation, what these two bits are? You can see a ficus. What's a ficus mean? The water bearer. So what is he bearing? It's not water bearer. That's Aquarius. You got the wrong one. Snake bearer. So here's one part of the snake, and the other part is around here. And that's Serpens. On the left is, this bit here is Serpens caput, and this bit over here is Serpens cauda, which in Latin means tail. So the snake extends around his waist. He's grabbing one end of it there, one end of it there. So, and there are some interesting things there, but we're going to concentrate tonight on the ficus, which dominates the sky. So let's have a look at a ficus, just because I've done a talk on a ficus, a really long one before, so I won't dwell on it, but there are some very interesting objects for observers as well as for photographers in this constellation. So the serpent bearer, or the snake wrangler if you're American, This contains an amazing number because it straddles the centre of the galaxy. It contains a lot of dark nebulae, Barnard objects, and you know Barnard's catalogue of dark nebulae. So interesting man. So you know you've got the Twin Jet Nebula, or that's I won't show that tonight. That's that thing that looks like two rocket engines opposite each other going. It's just the most amazing object to look at. But I'm not going to dwell on it because we're not doing our full talk on a ficus. We're just looking at a few things that are interesting. The Ghost Nebula, Pipe Nebula, Snake Nebula, Ink Spot Nebula, and at least 5 or 6 globular clusters. So it's got a lot of interesting stuff in it. So, and in fact, if you look over here, look, just to show you, that's a very well-known star. I'll talk to you about that later. M107, which we'll talk about. And down here, M14, M12, M10, over here, M5, just to the left, which we'll also have a look at. So if you can picture a ficus, so remember, a ficus is actually on the celestial equator, and some people say it should have been a zodiac constellation because it straddles the ecliptic. Yes? Well, it wasn't in. Yeah, it wasn't in Ptolemy's original lot, but I don't know where it came. But people argue that it should have been a 13, but it didn't work out that way. It sort of upset the apple cart, so they left it there. So if you look at the top, you can see, before I point to that star, you can see the head of the scorpion up here at the very top. Okay, so a ficus is always straight under the front of the scorpion, and the scorpion is rising in the east. At the moment, it's crossing the meridian over the north. So, you know, by November it'll set. But in the meantime, ficus has got some wonderful things to look at. So I thought I'd concentrate on a couple of things. This is Zeta Ophiuchi, which I'll talk to you about later. It's a runaway star and a big one. But its speed is nothing compared to what I'm going to show you in the news section of stars. There it is there. I love that image. It's a Spitzer telescope image in infrared. I think it's travelling at some phenomenal speed. 200,000, oops, sorry, Lisa. 200,000 kilometres per second. Are you getting sound? Sorry. If it falls off and I crunch on, there we go. Still okay? Okay, so let's move on. So an amazing star. Have a look at an O-class star, which means it's very hot, because O, B, A, F, G. So O is a very hot class. What's the hottest class above that? Anyone know? Before O, there is W, Wolf-Rayet stars, which are up to 80,000 degrees Kelvin and sometimes 100,000 degrees. So like the stars in the middle of 30 Doradus, which are Wolf-Rayet stars. Anyway, blue main sequence star, 0.95. Everyone know what the V means? V means it's an ordinary main sequence star still. So it was a big star to start with. Magnitude 2.57. So a Cepheid variable. So 460 light years away, but a very interesting star in its own right. I'll talk a bit about it later. Some of these others, Russell Huggers Alpha, we won't dwell on that too much. I wasn't going to dwell on the stars so much, but globular clusters, very pretty little globular cluster, M10. Magnitude 6.4, you'd see that in binoculars, it'd be quite bright. Small, but quite bright. It's only, what was its radius? 19.3 arc minutes by 28. That means its radius is 9. That means it's about the size of the moon, which is 30 arc minutes across. Yeah, 14,300 light years away. So that's a pretty close, well, not too close, but close enough. Now, this one is very interesting. I've got a couple of pictures of it, the crucifix cluster. Have you heard of that? A globular cluster called the crucifix. Magnitude 7.9, a loose globular cluster, the diameter of 10 minutes of arc. And this one over here is a beauty, M5, magnitude 5.6. You would easily see this in binoculars. It'd be quite bright. And you wouldn't need powerful binoculars. 160 light years across, 24,000 light years away. The best one, it says here, well, it's not just, don't take my word for it, it's supposed to be one of the best globular clusters to look at. Probably better than M4, which I like, which I'll point out to you shortly. And in fact, you can, no, you can't, oh yes, you can. That's M4. See that one there? right next to Antares. That's M4. So M5, just visible to the naked eye is a faint star in Serpens caput. So caput means tail, head, sorry. Caput, capitis, capital. Yeah, Latin. Sorry, can't resist the Latin. Now, this one, M12, magnitude 7.6, a distance 15,700 light years, a smaller globular, because it's only 75 light years across, but very quick. So here are some globulars you can take pictures of in a ficus or just to look at and admire. Now, this is a really high resolution image of Aurora Phaiki and the galaxy. In fact, I hadn't seen this before and didn't know it existed because you always get Bernal Andreo's one. But I actually prefer this because it's finer. It's really fine. I reckon it's been taken with a 20-inch plane wave or something. It looks so sharp. Or a very big refractor or something. I don't know. Maybe it's a mosaic. But it's super, super fine. Now, I'm showing you this because I'm going to be talking about some of the objects in it. And if you want to get a positional view, you can see down here, here's the blue horse head. Here is, in fact, I'll turn that off. That's annoying. Okay, so this area here is Roa Phaiki. There's Roa Phaiki, triple star. Can you see that? It's 3 stars. Up here is M4, the globular I was just telling you about, very close to Antares. Worth looking at, but I don't know if it's a great photographic subject. But this star here in front of it is Alniat 1, and that's Alniat 2, and the Scorpion's body comes up here to Larawag, and then up, it curls up around there and out of sight. So we can't see the rest of it. So down here is the left thigh, the left thigh of a pike of the snake wrangler, or snake, is down here and stops, goes through there. So this is a ficus down the bottom. Has everyone worked that out? So if you get your bearings, a ficus is down here beneath the double stream, dark stream, and here is, what do we call this thing here? Everyone know? This thing here. There's the head. There are the legs. The dark horse. No, that's a horse. So, but they've chopped the horse up into different things. Like the rump end of it is called the pipe. See the pipe with the end of the pipe, and then down here and on this area, oh, you can just make it out. There is the snake, and above it the ink spot, and these legs. This front leg sort of joins up with the stars back. I think that's Ida Scorpii, one of those. So, and the blue horse head down the bottom left. You can all see the blue horse head. And can anyone remember the name of the star before I leave this down here, which forms its eye, apparently? A bit low for the eye, but anyone know? The famous septuplet star, Nu Scorpii. Heard of Nu Scorpii? Jabba. Common name Jabba, proper name Jabba. Not that Jabba, but yes, spelt similarly, but not quite the same. Anyway, that's Jabba down there. So anyway, so let's move on. So get that. You look. If you look over here, you can see the Lagoon Nebula, the Trifid Nebula. Further down here, you'll go. Oh, look at that! Look at that mystery object. I'm going to show you that in a moment. Because this is the Sagittarius star cloud. See it there? That's the top of it. And it goes down beyond that, and that lovely object, I've got a picture you've never seen before of that, which I've taken. And up here, of course, you know where the scorpion's tail is, because the first thing you come across under the scorpion's tail is a prawn nebula. The bug nebula is somewhere in there. There's a cat's paw and the lobster or War and Peace nebula. And I don't know what that is under there. Can you help me out, Eugene? Do you know what that is? It's a great big red patch, but I never know the name. Anyway, next to it, if you look at it, there. Let me know if you. No, the prawn's up there. Prawn's at the top. They all go down in an order, but yeah. And what's this thing? Anyway, you can see how vast it is. It's, oh, now that one there is the butterfly M6. Sorry, not M6. The butterfly cluster, and to the right. Oh, that I don't know. Couldn't tell you, Mark. But this is overexposed. I mean, this photo is overexposed because this is blinding, and you can't quite see everything. And I think even all of this looks, I don't know, it looks a bit overdone. But if you look over here, see over here, there should be, now it's lost. The Ptolemy's cluster should be about over here, and it's lost. You can't see it. It's been blown out by the overexposure on the right. Anyway, what a fascinating part of the sky. So this is sort of what I'll be looking at, well, some of this anyway. There's a close-up of the rear of the horse. And look at the beautiful nebulosity. So this is Barnard 59, the pipe or stem nebula. So they've broken the horse up a bit into pieces. Now down here is a fascinating thing. This is the Snake Nebula, Barnard 72. And you can, it's actually quite extensive and surprising how that could fill your frame, which I'll show you later. It's quite, I'm going to take a picture of it sometime. And that's the ink spot. And I have never seen anything blacker than that. I've seen a close-up of it. It is just absolutely impenetrable. It makes the coal sack look like grey, not black. It's jet black. You can't see a thing behind it. I mean, even that looks pretty dark, the rest of it. But this thing, wow. So ink spot is an appropriate name. I don't know why they're taking so long to move these things. It's all in slow motion. Oh, well, it's appropriate. My age. Tauroa Phaiki Cloud Complex. So now you know where we are. So if we look up here, here is the leg here. The front of the horse is down here. The front leg goes back to where we looked at, the Tauroa Phaiki, the beautiful colours of Tauroa Phaiki. Everyone got their bearing? So we're at the centre of the galaxy here. So let's move on. Whoa, Ophiuchus. A couple of things I wanted to show you there. A little spot up there. There's the end of the pipe again, but a bit of detail about it, Barnard 59. This is a surprising thing I discovered. It's only 600 or 700 light years away. I thought it was thousands. I thought it was a lot closer to the centre of the galaxy than that. I thought it was thousands of light years away. No, 600, 700. So that thing is blocking a lot of stuff out pretty close to us. And it consists of the pipe stem, which we talked about, and the other Barnard objects and the bowl of the pipe. So down here, you've got that Snake Nebula. Now, and the ink spot is that bit there. And boy, wait till you, I haven't got any close-ups of that. So another dark nebula, Barnard 72, 650 light years away. 37 by 17 arc minutes. So bigger than the full moon. That's quite a size. So, you wouldn't need a lot of magnification to, if you were taking photos. Now, observation-wise, I'm going to come to that. It's quite difficult to observe. Here's Barnard 72 in the camera frame and eyepiece. So over here, I've got my camera, which is an APS-C camera, and my small 4-inch refractor, and that's the scale I get now. My sensor is nearly 2 degrees across. So that's not bad. Even for a small telescope, you'd get a decent picture out of that. If you were, and you get some of the surrounding area as well. And now here is the same thing, but with my 6-inch refractor and the same camera. So that's the difference between the 6-inch and the 4-inch. But that one's, the one on the left is 1200 millimeters focal length. The one on the right is only 700. So there's a significant increase in the size. That's why there's a big difference. I just did this for comparison and for my own information in case I start doing some photography. So you can see, and visually too, you'd get a very similar result if you were. So now this is a visual representation. This is a 20 mil eyepiece in the big telescope, a 1200 mil. So 20 to 1200 goes 60, so I've got 60 magnifications. Way too much really for looking at a dark nebula. If you're going to look at, I just want to illustrate the size. If you're looking at a dark nebula, get a white, like an 80 mil wide angle refractor to get in more of the surroundings, and everything is brighter to look at. You'll get more contrast. Under high magnification, you lose the contrast, and so the dark bits don't stand out. Does that make sense? Like they should. Yeah. So it's purely a function of magnification. excessive magnification. So even if you've got a light bucket telescope, a 12-inch telescope, if you're going to use high magnification, it defeats the purpose because you're getting more light, but you're trading off with magnification. So the image won't be as much as you'd expect, as bright as you'd expect, or contrasty for that matter. So dark. I was reading a guy who does this sort of stuff and loves dark nebulae. Said dark nebulae test sky transparencies and darkness, telescope and eyepiece baffling, observer experience, and field of view vis-a-vis aperture. So all those things are tested. So you've got to have good sky conditions as well. And he says the best thing is an f4 scope with a low power, 80-degree field of view eyepiece, which yields a 2-degree field of view, which is about the size of that camera frame there. Best of all is an f3 scope. Yeah, we can all get an f3 scope, a RASA or something, which takes advantage of the ultra-wide 100-degree apparent field of view eyepieces in order to yield the same 2-degree field of view, but with the greatest contrast because it'd be brighter because of the fast focal ratio. Don't forget to try very large binoculars. Dark nebulae are stunning through such instruments. Even 7x50s used in very dark skies will ferret out most of the dark nebulae, though many will be, of course, small in size because you only got 7 magnifications. Okay. So, a bit more on a ficus. Now, there's the front of the Scorpion. The Dark Horse Nebula, this is just positioning things. There it is on the right there, as we saw. Now, let's go on. I'm not going to dwell on this. There are so many. This is from my original presentation of 2-3 years ago. And I wasn't going to go through all that. But there are a couple of interesting things. You always see these two stars. I forget how far apart they are. Yed Prior, that one's Prior, the one in front, and Yed Posterior, the one behind. There's the Zeta Ophiuchi, the star I told you about that's a rogue star, runaway star. And what else? Oh, sorry. I'll leave that. I won't go through that. I won't go through all that information. Too much information overload. So I just put it in there to show you that if you're interested, I can always show you that at the end. So all those stars are very interesting, but they're faint. You know, you're not looking at 0 magnitude or 1 magnitude. You're looking at 2 and 3. And that's pretty dim. Now looking east. Now, of course, this is a wide field of view here. But of course, what's dominating the east now is Sagittarius. And at 7 o'clock on the 15th of August, if you look up, Sagittarius is about halfway up the sky. So let's zoom in on Sagittarius. Now, you might remember my Sagittarius walk, from about 2 years ago, 3 years ago. Anyway, we'll see. This is an interesting part of the sky. To the right is Corona Australis. You can see this with the naked eye on a clear night. You don't need binoculars. You can see that. But this constellation has the weirdest shape. And we all know what this asterism is called. It's the teapot. Now, I'll show you the teapot shortly. But if you look to the left, I meant to go back the other way, sorry. I meant to show you something else. Over here, there's the lagoon. And as you come down here, there's that M24 is the Sagittarius star cloud. And in it to the right, you can't quite make it out, the M's in the way, is the little IC 1284, which is a beautiful little nebula, which I'm going to show you that I got in my picture later on. And then down there is the eagle, the horseshoe, the eagle, and other. So here's a picture I took ages ago. So we'll have a look at what's here. There's Sagittarius again. Now we're going to do a little bit of star hunting. Now here is the handle of the teapot. Everyone see that all right? Is that visible, Ken? Okay. I should have used red lines. Now, just to show you the teapot. Now, the teapot doesn't stand out as much here because, for one simple reason, not only because I've got faint lines, but also because the stars, because it's a photograph, the stars dominate, the background stars have started to dominate the picture. So these stars, which are actually visible to the naked eye, easily, the pattern on a clear night, you can see this is plain as day, the teapot. Now, if you look at it, so there are some really interesting names, which I'll explain to you in a moment. A lot of Arabic names. Now that bit there, that extends out. These extra bits that I'll put on here, sorry, are beyond the, and this goes right round. I'll show you. Okay. Those two stars there are Arkab. I'll come back. Sorry. Those two stars on the right. There's supposed to be an extra little doodle-lucky there. Oh, sorry. Come back. Right. Those stars there, there's supposed to be, I just used one line, but that one there, both of them belong to, you can see a bit of coma there. This is taken with my Voigtlander lens, so beautiful lens, but really rotten, wide open. You get vignetting and you get, but at f4, it's as good as my Zeiss lenses. It kills them, in fact. It's got it's amazing lens. So if you want to buy a nice lens, a Voigtlander Nocton, and if you were taking daytime photos with it, wow, beautiful tonal range and everything. Anyway, I digress. So if you look over here, the stars have got unusual names. A lot of them are Arabic names. That thing keeps getting stuck. So let's have a look at it. So just to give you a picture of what it looks like, the top stars, Al-Nasl. Lots of Arabic things. Now, Caus Australis means southern Caus. Caus Media, middle Caus. And then Caus Borealis, northern. Because in the nighttime sky up north, this is the other way around. So when the stars were first, yes. I don't know. I did know, but I don't anymore. Caus. No, I can't remember. I didn't even bother looking that up. But I love the names. Some of these are very Greek, like Polis over here, which is, remember that yellow line that comes out from the edge of the teapot, from the top of the teapot. So very interesting objects. So here are some of the names: Arkab Prior, Arkab Posterior. Lots of Arabic names there. Very prominent constellation. The Lagoon Nebula, the Trifid Nebula, the Great Sagittarius Star Cloud M24, and then down here you've got the Horseshoe Nebula or Swan Nebula. You call it what you like. Have you ever seen where the horseshoe is? It's right at the end of it. I watched the video. I thought, you've got to be kidding. The Omega. Sorry, that's the other name, the Omega Nebula. And when you see the Omega Nebula, there's a little Omega. I mean, you have to use your imagination. I don't know how they got that. And that's the Eagle, of course, down there, M16. And that's Jupiter down the bottom, looking very bright. When I took this photo, the ecliptic goes straight through there. And there's Corona Australis over on the right here, making a lovely little sweeping U shape. I haven't done a talk on Corona Australis. Oh. Yes. The bow. Yeah. There's something to do with him. I thought it was because his arrow is Al-Nasl. So that one there represents where the arrow, the top of the arrow, where the arrow comes out. There's one over here, another star I haven't got there, called Hamalwadira, I think it's called. And that's off the picture. I didn't put it in. I think it's that one there, actually. I think it's that guy there, right there. Anyway, let's move on. So, deep sky objects. Look at them all. Lots of messier objects, obviously, in this area of the sky, because you look at the center of the galaxy. But the ones that I'm most interested in are the ones I pointed out, M8, M20, M22. M22 is a beautiful globular cluster. Has anyone taken photos of it? I know Steve loves this globular cluster. It is gorgeous. And so I'll show you a picture of it shortly. The Great Sagittarius Cluster, it's called. And over here is the Great Sagittarius Star Cloud M24. Magnitude of 2.5. It fills a significant volume to a depth of 10 to 16,000 light years. So it is virtually, they say, 6,000 light years thick, because it's just all the stars in that area. It's a bright patch of the Milky Way. So it's very, very densely packed with stars. There are two clusters in it. I had a look at them. A Bok globule also nearby, but very dense. So there you go. Now, here's a nice picture. I forget who took this, but you can see that's taken with a pretty good instrument, high quality instrument. Now that little subject there, that's the IC1284. That's what I want to talk about because I love this little thing, and I'm going to take another picture of it sometime. M24 is about 600 light years in width. This is the cloud itself, 600 light years across, magnitude of 2.5. 1,000 stars can be seen in the field with binoculars. So if you can sit there all night, put your binoculars on one of those stands and just stare at it for a while, and you pick up all these wonderful stars. Described as a virtual carpet of stellar jewels. I don't know who said that. Maybe that was from Burnham or somebody. M24 is visible to the naked eye whenever the Milky Way itself is visible at all as well. So there is IC1284. I'm going to talk to you about that in a moment. Here's the Great Sagittarius Star Cluster, the globular cluster I just mentioned that Steve loves. Now, magnitude 5.1. That's very bright. You would see that easily in any binoculars, small telescope, medium telescope, large telescope, quite a sight. Northwest of Caos Borealis, 300,000 solar masses, the usual age, 12 billion years for a globular cluster, 10,600 light years away, and the size of a full moon. And it's one of only 4 globulars known to contain a planetary nebula. And 2 black holes, between 10 and 20 solar masses each, have also been discovered inside it. Okay, so there's a very pretty cluster to look at, M22. Now, here's a wider field view. If you look over here, here is the Sagittarius star cloud. There is IC1284 on the right. Down here is the Omega Nebula. Everyone got their bearings? So, what is this gorgeous thing up here? Hang on. There. That's M23. Another interesting cluster that I intend to have a look at for observing, because look at it, very pretty. Nice star field, and right in the middle of all this other interesting stuff. Of course, if you combed this with a telescope, you'd spend half the night looking at it, this area of the sky. Yeah, so there's, oh, sorry, I didn't mean to do that, but that's a Beta Hyperion. Yeah, that's looking at it. That's a view at only 38 magnifications with the big telescope and my Beta Hyperion 31. So it doesn't matter what you use, around about 38, 40 magnifications, that's how big that cluster is. Of course, you'd use a higher magnification because it's reasonably bright. Now, let's have a look at IC. Now, this is my picture. You're looking at its premiere. I mucked around with the development of it because I found it quite difficult, especially because there was so much stuff over here, nebulosity, so I cooked it a bit. But what I want to bring up, this is just gorgeous. And that's what I would like to photograph close up. Yeah, using the Antlia triband. So that would be an interesting one. Because look at the blue, look at the beautiful blue nebulosity. So reflection nebula and emission nebula in one. Reminds me of the Trifid. So that's a very pretty part of the sky. And things that remind you of the snake and the down here, look at this. This is very, very bright. And up here at the top there's one that looks very similar. Look at that one. So the star cloud is the densest, come back, sorry. The star cloud is the densest concentration of visible individual stars visible in binoculars. 1,000 stars, 2 by 1 degree, and we mentioned that its diameter is already 300 light years across. That's the thing on the left. That's all of it. Oh, this is a close-up view. So, and this was taken with a small telescope. So, my 4-inch refractor. Yeah. No, native size. So you can get an idea, if you use something with high magnification, you get that nebula IC1284 pretty quickly. So let's have a look at this next one just quickly. There it is. There's another thing. This is a view. This is a view of the Sagittarius cloud and IC1284 together using a pair of 7 by 50 binoculars. That's all you need. And that would be stunning. And it would be very, very bright. I doubt you'd see much of this little fella here because it's an emission nebula mostly, and it wouldn't show up terribly well in your binoculars, but you would still see the star cloud pretty easily. And there's a close-up of 1284. And this one is using my little telescope, a 4-inch telescope, and a 7mm eyepiece, giving a magnification of 100 times. Again, probably useless. You might see the bright stars, but you wouldn't pick up the nebulosity. Okay, so you wouldn't expect to. But just to give you an idea of framing sizes, and this one is with the larger telescope, a Celestron, 9¼ inch, which I was thinking of buying for all our SCT fans. Thought of you, Lisa, when I put this one in. So this is with a Pentax 20mm, giving you 117 magnifications. It would easily fill the field of view, but I wouldn't do it. I mean, if I was looking at this, I would, even with a big instrument, I would use a low magnification. You get a punchier contrast image. Photography is a different thing, but this is just visual stuff I'm showing you here. But the binoculars are handy. You don't need big binoculars either. So back to the Sagittarius cloud for a moment. Down here is another cluster. This is M25. It is beautiful. And it's another one worth looking at. Magnitude 4.6, boy, that's an easy target for a pair of binoculars or anything. 32 arc minutes in size, which is very significant. Size of a full moon, 67.6 million years old. It's very young. You can tell that by the colours of the stars. Best in small telescopes. Contains 2 red giants. One of them is a binary. 601 known members. So there is a cluster to pin up. Note that one down, Roscoe. Should I be addressing members of the audience when I'm doing so? Whoops. Hang on, I've lost my... We're having a sound problem. Just a moment. Hope no one's going to watch this on YouTube. Are they? Oh, okay. Now you've made me nervous. All right. Now,
People switched off the World Cup.
oh, the World Cup. Yeah, isn't that a disgrace? Don't get me started on that, how it's not televised. I mean, I think it's pathetic. Absolutely pathetic. Sorry. So there you go, M25. Keep that one in mind. Very fun. You're a comedian, man. Now, back to this. So one last thing down here, of course, well, a couple of last things. A famous M17. Here it is here. Now, this is the Swan Nebula, Horseshoe Nebula, Mega Nebula. And if you look over here, this part of it, I'm going to show you something stunning later. I won't tell you when. But that is really interesting in infrared. So, beautiful cluster in that. Lots of stars being born. You can see it's an emission nebula, 800 solar masses, 15 light years across. It's not that big, really. I mean, Orion Nebula is 30, so give you an idea of scale. 800 stars, but 100 of them are B9, very hot stars. 1,000 stars in that formation. So there you go. So if you get your bearings, guys, here's the lagoon, here's the Trifid, come down a bit, there's the Sagittarius star cloud, straight underneath it is the Horseshoe Nebula. Now the other one over here, you might guess, is the Eagle, Eagle Nebula, and we'll do a close-up. Now, I was going to show you, I wonder if I should. I think you might enjoy this. Let's have a look, if it works. We'll come back to the show after this. Yeah, it's coming up here. Oh, I know what to do. I've done this before. Sorry.
The Omega Nebula, or M17, is a star-forming region in the constellation Sagittarius. It is about 6,000 light years away. It gets its name from the dust cloud that, in visible light, looks like the Greek letter Omega. In infrared light, that dust fades into transparency. Nebula more resembles the Roman letter V.
Yes.
A cluster of huge stars lies at the heart part of the nebula. Some of them are over 40 times as massive and 100,000 times as bright as our sun. Such stars produce strong winds of charged gas particles that flow outward and sculpt the shape of the nebula. Nearby, less massive stars are surrounded by curved bow shots. These glowing shells form where weaker winds from the smaller stars slam into the stronger winds from the distant cluster. The bow shots act like weather vanes, showing astronomers which direction the interstellar winds are blowing.
They've retired Spitzer. I think I might have told you that before, or you might be aware of it. So anyway, oops. Let's just go back to our show. Slideshow from current. Oh no. Where are we? Okay. So we've just done that. So that was the Omega Nebula anyway. So you know where it got its name. A nice little, and that's the Eagle Nebula, one of my pictures. This is just a beautiful thing. I'd love to go and take this with a different filter though. And I think this was with Big Bertha, the 6-inch refractor. And you might recognise the Pillars of Hercules. Pillars of Hercules. Sorry. What do you call them? Pillars of Creation. And they're the two claws, yeah. I think that one. People sometimes get this confused, this one here, with the Elephant's Trunk Nebula. But it's not. The Elephant's Trunk Nebula is in Cepheus, which is the northern constellation, which we can't see. Sorry? Yeah. Yeah, and it's in a different constellation. So we can't see it here. Anyway, that was taken with a Optolong L Extreme. Eugene's Optolong L Extreme, I should add. I know you're getting sick of this one picture, but it's got a lot of interesting stuff in it. Here's a super cool graphic I've made. Okay, so looking that way, the Lagoon and the Trifid Nebulas together, you can get them both in the same field of view. It just depends on what your arrangement you've got. But wonderful, I'm going to try and take a picture of the two of them together. That's a plan later this year. Yeah. Yeah. So the Lagoon, you know well, it's not a terribly big nebula, but it's very, very bright. I have seen that in binoculars, and it's stunning. In binoculars, stunning. So say 10 by 50 will blind you. It's so bright. I was once, we were out here, and I don't know if you were there that night, Maddie. We looked at the Lagoon. My jaw dropped. It looked better than it did through a telescope because it's such, you know, the binoculars offer you so much light and contrast, and it was spectacular to look at. So sometimes binoculars rule, and I think in this case it's a really wonderful thing to see in binoculars. So a lot of the warm O-class stars in it, so a lot of information there. Bok globules, where you can see those, they're everywhere. These little dense pockets of gas. And what was it? Yeah, 4,000 to probably 5,000 light years away. Anyway, visible to the naked eye quite easily. Now, underneath it or next to it is the Trifid Nebula, which we just saw. And there's a lovely picture here of the Trifid on the right. Now, I think, from memory, what was it that with? The Subaru telescope, Hubble telescope, processing by Robert Gendler. You might remember Robert Gendler. Oh, he did the best Andromeda I've ever seen. Anywhere. Beautiful, beautiful image of Andromeda. He's a really good processor. And I think this, I'm not sure whether that's filters, swapping filters for colours, red, green and blue. You know, I don't think it's infrared. I think it's a, huh? No, it's just reversing colours. Yeah, using different colour palette. But anyway, it's beautiful, isn't it? Spectacular. Talk about high resolution. And there's a typical thing that we might take, you know. We were showing that it's a reflection nebula, an emission nebula, and dark nebulosity too. So it's got everything going for it. Sorry, I didn't mean to go so fast. But I don't think if you looked at that through binoculars, you wouldn't actually see, you wouldn't see the nebulosity, you would see the bright stars. So here's an example of the field of view with a binocular 7 by 50. And it's yes, it's small, but it's concentrated and very bright. And you would probably be amazed. And you can see the Trifid on the left there, just down here, there. So, and the next thing is the same thing, but at a view of, this is my Beta Hyperion and the small telescope, the 4-inch refractor. That's the field of view at a magnification of, what was it, 22.7. So it's a very low magnification. You would get that if you had 20 by 50 binoculars, virtually. It's only a bit smaller. So binoculars would be fantastic on this object, in my opinion. Now over here is the lagoon, but with my larger, same telescope, but with a Pentax 10. That gives me a lot of magnification. In fact, 70 magnifications. But you would get away with it with this because it's so bright. You know, it's a trade-off. So you probably see quite a good amount of detail with a, it's not a big magnification, it's a medium magnification, but it'll still be bright because the object is inherently bright. Yeah. Okay, so I just want to show observers what they might be able to see. Now this is Caldwell 57. Named after Barnard. Another, I don't know if you know about the existence of Barnard's galaxy, but I didn't. But Barnard's galaxy is right there, and we're going to have a little look at it. And these two, this is facing east, this is underneath Sagittarius. You can see Sagittarius, the jellyfish cluster, and Barnard's galaxy. So let's have a look at those two. And down here is Saturn at the moment. So this is 15th of August. Now that's 7 p.m. By 9 p.m, it'll be up another 30 degrees. So Saturn will be well up into the sky by 9 o'clock on that night. Remembering that we're looking at roughly 15 degrees an hour rotation. So if you're patient and wait, you'll be able to see Saturn. Saturn's going to look gorgeous. Now, the Alpha Capricornus meteor shower. Has anyone taken pictures of meteor showers here at all? You, Dallas? Have you? Yeah. You get a few. Did you get the zenith? Where the what do they call that? The radiant. Yeah. You got the radiant. Oh, that's good. So there you go. That's the Alpha Capricornus meteor shower, 3rd of July till the 15th of August. So watch out for that. That's something you can get. Zenith hourly rate of 5, so 1 meteor every 12 minutes. Something like that. The parent body is Comet 1. The thing that sprayed all that stuff is Comet 169P. If you want to know, comets and other objects, but mostly comets create a lot of the stuff that we go through that cause the showers. It was so bright. Gee. Wow. Now, you could be fooled for thinking that you're looking at the small Magellanic Cloud, but it's not. This is Barnard's galaxy, and it looks just like the small Magellanic Cloud. So it's like and it's the nearest non-satellite galaxy to our own. So it's only 1.6 million light years away. So this is really close, and it looks quite interesting. And it's those little red knots of nebulosity that I love, and I wish I could, you know, if you could zoom in on those. So named after Edward something, I forget his middle name, not Ernest, something like that. But no, I've forgotten. Anyway, in 1884, he found this with a 6-inch refractor. It just lies outside the virial radius. I think that means the tow, the gravitational pull of the Milky Way. So it's not going to be captured by it because it's just outside that field of attraction, if you like. 7,000 light years in diameter, magnitude 9.3, so it's pretty faint, but you would pick that up with a telescope quite easily. 15.5 arc minutes across, and there he is. There's the man. Oh, that's his name there, Edward Emerson. I was trying to think, Emerson Barnard. Famous for his catalogue of dark objects, which, anywhere you go, and it's got Barnard, for example, the Horsehead, Barnard 33. Remember that? Barnard 33. So I think it's amazing. Well, anyway, 6-inch refractor, that's what he found it with. So gives me hope. Maybe I can discover something. Now, this, of course, is M30, the jellyfish cluster that I showed you in the last slide. Easily seen with a pair of 10 by 50 binoculars. So I've picked things you can pick out, forming a patch of hazy light, 4 arc minutes wide, slightly elongated from east to west, located 28,000 light years away. This globular cluster, a dense swarm of several 100,000 stars, is only 90 light years across, which makes it small. That's about less than half the size of Omega Centauri, which is about 180 light years across. But magnitude 7.2, that's good. That's quite easy to see. Up to 12 arc minutes wide if you've got a decent sized telescope, big telescope. You can see more detail. So there's another globular. I like the little arms coming out of it. It's got an interesting little shape. The jellyfish cluster. It does look a bit jellyfishy. Anyway. So there's Barnard's galaxy. As I said, boy, does that look like the Small Magellanic Cloud, like a sister of it, practically. This is a view at 171 magnifications. So you can fill your field of view with about 170. Field of view is what, 0.4 of a degree, less than half a degree. And there it is at a wider field. We're using a Pentax 20, 117 magnifications, so significantly less, and a Schmidt-Cassegrain 9.25, which I was thinking about getting. Still in the hands of one Lee Bryan, I think. He's still got the 9.25. Is he? Oh. And here's the jellyfish cluster. So the magnification there is pretty, what was that, 7 mil on my telescope gives you 100 magnifications, yeah. Oh, don't forget. When you get low magnification, the exopupil, the cone of light coming out of the eyepiece, is big, which is good. But when you've got high magnification, you know how you look over and you can't see it? And you get a flat spot and you can't see a thing? They call it like blacking out. That's because the exopupil's tiny. Like it might be 0.5 millimetre or 1 millimetre. And you think of a 1 millimetre wide cone of light. So you've got to get your eye in exactly the right spot to see it. And as some of us are old, the maximum width of your pupil is 5 mil. So if you get a pair of binoculars, say, which will give you, like 7 by 50s will give you a 7 millimetre exopupil, because you divide magnification into the size of the objective. 7 into 50 goes 7. So it's wasted. 2 millimetres, the cone of light is wasted because your eye's not seeing it. It's going to be very bright. Your eye's not unable to take it all in. So that's something to consider when you're doing observation. Anyway, so Saturn on the 15th of August is going to look like this. Now, you remember my talk on Saturn? You might remember a few weeks ago. When you look at something like this, you have to realise they're not in order. You know, they're all over the place. It's three-dimensional. And you don't know where they are in position, but you just got to remember, like a mnemonic about the order of things, you know, starting with from the F ring and moving out. And you can, oh, sorry, didn't mean to let that go. Oh, sorry, let's go back. I must have clicked something. Come back, just quickly. Yeah, so opposition. Saturn is opposition, 27th of August. So that'll be the ideal time to take our photos if you want to. And Schmidt-Cassegrains will rule, and that'll be the time to do things. Rise at 6:30 p.m. Currently in Aquarius. On August the 3rd, the moon will be 2 degrees from the planet. 2 degrees from Saturn. That's not far. That's a bit over a finger width, 1.5 finger width. That's close. Anyway, so there you go. That's the spread. So through your telescope would look wonderful, even just for observational purposes. And Jupiter. Of course, the Galilean moon's always a favourite, but it's not looking particularly spectacular at this time of year. And it's rising in the early morning, like 2 a.m. or 3 a.m. So, in fact, I don't know if I put that detail in there. Oh, 12:25 a.m. on August the 15th. At the moment, it's about 2 a.m. That makes sense. So at the moment, it's rising at about 2 o'clock in the morning. You can always see it in the morning sky anyway. Did anyone see? Oh, yes, you did. The Starlink satellite things the other day. Did you see that? Headed straight through Orion in the early morning. It drove me nuts. I looked at it and people go, oh, isn't that pretty? It's a pain in the neck. I was thinking if I was taking photos. Anyway, I called Cinta out. I said, look at this. And she said, oh, yeah. She was underwhelmed. Yeah, Elon Musk. I don't know. Anyway, from the 19th to the 24th star, Sigma Arietis will be visible along the plane of the moons. So there'll be a star, Sigma, this is in Aries at the moment, Jupiter's in Aries. So there'll be a star somewhere through here along the plane of the Galilean moons, which will be very interesting to see. I can see why people complained about this thing. It gets stuck. Very annoying. So looking south. I won't be long. I'm zipping through this. So south, the usual culprits. So I decided I wouldn't dwell on all the things I normally dwell on because I've dwelt on them many, many times. So what I thought I'd do is talk about the Magellanic Cloud just for a moment. Because the small Magellanic, large Magellanic Cloud, now look at this. A little trick, if you want to get stuck finding the South Pole, you do that. You triangulate. Now it's not exact, but it's rough. And it'll get you roughly in that area if you're trying to find the South Pole. And then you can use another technique. Hang on, Achernar and Canopus, which dominate the sky. By the way, yesterday morning I looked up, Canopus was high up in the southeastern sky, so Achernar was over there somewhere. But I looked at Canopus, and next to it to the left was Sirius, and I couldn't pick it. I couldn't pick the brightness difference. Even though Canopus is the second brightest star, it didn't look that way. And another thing that floored me was the false cross. Next to, you know the stars in the false cross. So you've got Kappa and Delta Velorum, and then down here, the bottom one is Avior, and over here is Aspidisci. Well, the top two, they're weird names, Markeb, and this one here, which is Alcifina. Well, it was upside down. And so Alcifina was down here, and to the left of it, I could see a little patch of light. And I thought, that's a star cluster. And I can see it with the naked eye, not even with my glasses on, my long-range ones, which I'm wearing now. And I looked and I thought, I wonder what that is. I thought, I know there's a Gamma Velorum cluster nearby, but that's not Gamma Velorum. So I looked it up and it was Omicron Velorum, and its magnitude is 6.1. So for a blind guy like me, I could see, this is how good the sky was, I could see that with the naked eye. 6.1. So even an old geezer can see 6 magnitude on a good night. So sky conditions are really important. You know. So anyway, false cross. Have we got in the picture? We should have. Yes, we have. Here it is. So if I just come over here because this will get stuck. Here we go. Here they are. Markeb, Alcifina. So Kappa and Delta Velorum. So this is Vela, Velorum, Avior, and Aspidisci. So Epsilon and Iota Carina. So these belong to Carina. So, and down here, of course, the famous, well done, I was testing, well done. There would have been an electric shock if you'd missed that one. You refused. Anyway. Oh boy. Anyway, I love the Sprinter. The Sprinter, though, in a telescope is a wonderful thing. I mean, it is a beautiful thing to look at. Even if you don't photograph it, it's just spectacular on a good, clear night. So there you go. So the cluster I was talking about is right to the left here. I don't know if that's it. It looks like that's it there. This fuzzy little patch here. But that's Omicron Velorum. So Now, there's the South Pole, right? So let's do another little triangulation using Achernar and Canopus. Here's another triangle. Oh, sorry, didn't mean to go that fast. So that works, see? So there's two ways of finding the South Pole if you get stuck. But that's not the purpose of this discussion. So I was going to talk to you about the Small Magellanic Cloud. And notice the similarity to Barnard's Galaxy that we looked at earlier. And a view down the bottom here with 7x50 binoculars. This is where binoculars come into their own because they've got a wide field, you don't need high magnification, and they look pretty. And if you've got time, put them on a stand and you've got an ideal setup to do some observing. Over here, the Large Magellanic Cloud. Oh, distances. So, Large Magellanic Cloud, 163,000 light years away. Some people go as high as 168. The Small Magellanic Cloud, 200,000 light years away. So both with millions and millions of stars, billions of stars, but not like the Milky Way, nowhere near it. But I draw your attention to the famous, appropriately with the green pointer, 30 Doradus, or the tarantula, which we might have a look at shortly. So, so there you go. So there's a view on the bottom right through 7x50s of the Large Magellanic Cloud. So 7x50 binoculars are useful for looking at some of these things. And if you're prepared to spend the big bucks, you go for the Canon 10x42s, image stabilized binoculars, $2,400. But you put the switch on and no more shakies. And you can look at these objects, handhold them for ages. And you get 10 magnifications and a spectacular optical quality, which would match Zeiss and the others, because Canon have put their best optics into those binoculars. So you get what you pay for, basically. But you break into a sweat at the same time. Anyway, so there's the tarantula. NGC 2070, as we know it, very fondly. And over here is a close-up. Now, those stars that I was telling you about, biggest, most massive stars that we know are in this cluster called R136, which is this cluster here, right in the middle, causing it to glow. There it is there. And the biggest star in the middle of that is R136A1. Scientists think R136A1 is a binary, a double star, you know, a bit like Eta Carinae. But others say no, it's a single entity. Split opinion about it. Anyway, these are all Wolf-Rayet stars. 300 times the mass of the Sun is R136A1, the most massive star known. That doesn't mean it's the biggest star, it just means it's the most massive. Its size, I think it's 40 times the size of the Sun. So it's tiny compared to Betelgeuse. But Betelgeuse is a puffball, you know, with low density. Oh, my Teleview eyepieces. I put in the panoptic. I would love to see this with the big telescopes. I put in there 50 magnifications. That's what I'd see with the tarantula. The panoptics are beautifully sharp. So with my binocular viewer, wow, I would love to observe that and see what I could get with Big Bertha. So, Big Bertha is a telescope, by the way, to those who don't know what Big Bertha is. Probably wondering what's happened to me. I've gone berserk. Virgo is setting. So you can see, oh, by the way, star Spica, an interesting star, very blue. Has anyone looked at Spica through a telescope? Talk about blue. It's dazzling blue. That's 250 light years away. And that's a binary, spectroscopic binary with both bits going so fast. I think it's 4 hours or 4 days they rotate around each other. And they're so close that they're, and going so fast, they're oblate. They're squashed like Jupiter, you know, squashed, but much more than Jupiter. And they're going to collide one day. So that's a really interesting star to watch. I suppose it'll collide a lot longer, well after we've gone. But anyway, that's Spica. And down here at the bottom, Mercury at the very bottom, Arcturus on the right, 35 million kilometres in diameter, but very low density, hardly bigger than the Sun, and about 37 light years away. So, but both lovely, lovely stars to look at in pictures. And the famous M83 pinwheel. Southern Pinwheel Galaxy. So they're things to look at in the west. Now it's still high enough at 7 o'clock. If you start at 6, you might get some nice snaps of it. And the Sombrero Galaxy too down in the west as well. So if we look here, we'll have a look at M104, the Sombrero. Now the magnitude of the Sombrero, it's not terribly big, it's magnitude 8.
It actually is right.
Yeah.
It's
Well,
one of the easiest galaxies to see as recognised galaxy.
yep. Well, they say, although it is visible with 7 by 50 binoculars, a 4-inch amateur telescope, an 8-inch telescope and a 4-inch, an 8-inch telescope is needed to distinguish the bulge from the disc, to separate them, and a 10 or 12-inch telescope to see the dark dust lane. This is for optical purposes. I mean, not taking photos. Obviously, if you took photos. Yeah, it looks like a, well, the top one is an infrared image, Dallas. So I don't know. It's amazing, but you're looking side on there. It's like it's a very interesting subject, Sombrero. Has anyone taken pictures of the Sombrero? Have you, Lisa, you have? Yeah. Long exposure? 5 minutes. Gee. Oh, well, with 8-inch. Yeah. So I guess Greg with his RASA would do things in 2 minutes and right. Yeah. No, a bit small. Oh, yeah. Oh, that's a decent focal length. Oh, right. Is it? Right. Okay, so there's the Southern Pinwheel, very pretty. Barred spiral galaxy between Hydra and Centaurus. And it's one of the closest barred spirals to us, visible with binoculars, 118,000 light years across. So that's a bit bigger than our galaxy slightly. Magnitude 7.6 and roughly 13 arc minutes across. So it's not gigantic, but it's big enough. Yeah, and 14.7 million light years away. So there you go. And the bottom one, the Sombrero, has 1,200 to 2,000 globular clusters. We've got 150 in the Milky Way. But Virgo A has, I think, 10,000 globular clusters or something in it. Something ridiculous like that. Virgo A being that gigantic, it's massive galaxy, supermassive galaxy. So, moving on. So here are a couple of pictures. Here's the at a magnification of 100 times, the Sombrero, and then the Pinwheel at also at with the 7mm eyepiece 100. Exopupil here, see 1 millimeter. I always have trouble. I love the view through my Pentax. 7mm, beautiful, especially for star clusters when they're bright. 1 millimeter cone of light coming in the eyepiece. So Southern Pinwheel at 97 magnifications using a 24 panoptic and a Celestron 9 1/4 edge, which would be a nice combination. And finally, a picture with a 10mm eyepiece and the Celestron 9 1/4 edge. And now we're looking at, 2,350 millimeters focal length divided by 10 gives you 235 magnifications. So that's a lot of magnifications. I don't know how much you'd see with brightness. I've never looked at it through a Schmidt-Cassegrain at that. Happy stargazing. Ta-da! And that's it, folks. And I think I had, the next talk we'll have after a break. Oh, God, it's gone long enough. Have a quick break. The next talk is very short. It's only got about 10 slides. There you go. No, just a minute. Sorry. At this rate, we'll be here till 11 o'clock. Oh, how does that work? Hang on. It's a clip, isn't it? No, it's all right. I'll put it on my shirt. No, that won't hold either. Yes, I did. I think I'll fold it over.
You've never worked in a newsroom, have you?
No. Uh-huh. Now it's all right. Can you hear me? Good. Okay. So, Mark gave me strict instructions not to call us News of the Month. So I chose something different because there have been some very interesting things happen. So I will just quickly go through them. So now you all know when I did that talk on Saturn's moons, if you were here, we talked about Enceladus. What's wrong with that picture? How bizarre. Yeah, it doesn't look, it looks 10 times better on my, it's the screen. Anyway, yeah, now we know that these water plumes are coming out of Enceladus, right? And they contain all these different minerals, hydrocarbons, all sorts of interesting things. But they also contain phosphorus. That's one of the recent discoveries. And also, some of them are so big. Now, Enceladus is about 500 and something kilometres in diameter. This latest plume is 9,000 kilometres long. So you can imagine the force of something like that. The water stream, 9,600 kilometres, a distance equivalent to that of flying from the UK to Japan. That's the length of the water spout. So it's obviously got a lot of energetic stuff going on underneath the surface of the moon. And of course, that stuff flies up and then some of it falls back down and must turn into ice straight away again because it's so cold and there's no atmosphere. But anyway, Cassini also found hydrothermal vents like we've got on the ocean floor. You know, those really, where the water's boiling and producing all these compounds. So I bet you they find life on that moon. Whatever form it'll take, I bet they will. So Enceladus is in the news because of that enormous water spout and the energy involved in expelling that much water at such high velocity. Now, Hubble's been looking for an intermediate sized black hole close to home, and they found one in M4. Remember M4, the globular cluster that I showed you next to Antares and Scorpius, the little one close to it. So, and they reckon they've found, because of the movement of stars and so on, we have good filaments, so we have a very tiny region with a lot of concentrated mass. It's about 3 times smaller than the densest dark mass that we have found before in other globular clusters. So there's M4. So it's still a pretty thing to look at through a telescope. And of course, as I showed you earlier, there it is there. And there it is in this picture at the top right there. So, and that's another one worth looking at, but you'll be a bit underwhelmed when you look through a telescope at it. It's not terribly spectacular as globulars go. There are other better ones, as we saw earlier. Now, a supernova discovered. Now, a Japanese astronomer, you may have read about this. What's his name again? Koichi Itagaki, very recently found this particular supernova. It took me about 5 minutes to confirm it was a supernova. He has claimed 172 supernova discoveries. The discovery was made in bad weather with lots of clouds. We were lucky. So there you go. In M101, we can't see M101 because it's in it's the northern pinwheel. It's not our pinwheel, so it's in the northern hemisphere. A type 2 supernova. So a type 2 supernova is where you've got a big star, massive star, and then it explodes. It's not a type 1, which is where you've got a binary system. You might have a dwarf and a white dwarf and a bigger star, and the white dwarf sucks material from the bigger star, and then the white dwarf exceeds the Chandrasekhar limit, which is 1.4 solar masses, and it explodes. And that expels the other star, and that's how you get runaway stars, often from type 1A supernovas. So, the other star is literally expelled from the system by the violence of the explosion. So, So there you go. SN 202 F3I9F, I'm not sure what that means, will likely brighten and remain visible to telescopes for months. Studying such a close and young type 2 supernova may yield clues about massive stars and how they explode. Anyway, it's in Ursa Major, so unfortunately too far north for us to see here. So keep track of that one. Now, I love this. Now, we all know Elon Musk's had his way with NASA. Well, enter Jeff Bezos, who's going to make, now you know about the Artemis missions, there are going to be 5 of them. He will. The whole plan is you get rockets with fuel and they go up above the Earth and they refuel the Orion, and there's a sort of like a, there'll be a space crater, like a, not a space lab, but a place from which the Orion spacecraft can take off. Then it'll go, Orion lander and another thing that comes off it. What's it called? Blue Moon. The Blue Moon lander. Bezos is building it, and it'll go around the moon, and then the blue lander will go down to the surface. So it'll take astronauts from the Orion down to the blue surface, if that makes sense. So that's the plan. And they've got 5 missions planned. The third one is the first of the manned missions, and that's not far away. And there's a mission next year, I think it's number one, 2024. The last one will be 2029. And of course, what they're going to do is they're going to set up a base and so on. It's called the Space Launch System. So the mission will launch 4 astronauts on a Space Launch System rocket, which will go up with the Orion attached to it. You've seen the Orion's at the top of that. No, not at the top of that, sorry. To the Lunar Gateway. So, and that will be the third lunar landing on the Artemis program. In addition, Artemis 5 will deliver 2 new elements to the Gateway space station. So the company will first have to demonstrate it can safely land on the moon without a crew. So they're going to have to do their own test landing. Bezos said he was honoured to be on this journey with NASA to land astronauts on the moon, this time to stay. Yeah. Yes. We want more competition. We want 2 landers, NASA's boss Bill Nelson said on Friday. I don't know what Friday that was. It means that you have reliability, you have backups, and NASA needs them, as we have seen. So anyway, so Jeff Bezos gets this contract to build the second one. Now, one of my old pictures of 47 Tucano. Now, James Webb Telescope finds evidence of celestial monster stars the size of 10,000 suns. Now, we talk about, I was just talking about the ones at the centre of 30 Doradus, so the Tarantula Nebula. Well, they're nothing. None of those are anything compared to these monsters. Look at this. And millions of supermassive stars. 10,000, not 300, 10,000 times the mass of the sun at the beginning of the dawn of the universe, born just 440 million years after the Big Bang. This is what the James Webb has discovered. And these stars could shed light on how our universe was first seeded with heavy elements. Because when those stars exploded, they produced all the heavy elements, including gold, silver, and platinum, things like that. Anyway, anywhere between 5,000 to 10,000 times the size of our sun, the fiery giants, down here I'm reading, burned at temperatures of 75 million degrees Celsius. That's mind-blowing. As bigger, brighter, and hotter stars die out, the fastest, these cosmic monsters have long since met their demise. They're all gone in extremely violent explosions called hypernovas, which is what you get when you get a star that's so supermassive. Globular clusters are between 10 and 13 billion years old, whereas the maximum lifespan of superstars is 2 million years. They don't last very long. They therefore disappeared very early from the clusters that are currently observable. To spot the scattered chemical residue of these monsters, the researchers trained the Webb telescope infrared camera on the galaxy GNZ11. Oh, they have fantastic names, don't they? Which is one of the most distant and ancient galaxies ever discovered, being 13.3 billion light years away from the Earth. Anyway, the strong presence of nitrogen can only be explained by the combustion of hydrogen at extremely high temperatures, which only the core of supermassive stars can reach. So they're interesting to study from that point of view. So that's one of the latest things that James Webb has been looking at. And now, Betelgeuse's brightening raises hopes for a supernova. Have you seen that woman from Cambridge University? What's her name? Rebecca somebody. She's a professor at Oxford. Not Cambridge, Oxford. She's a really good commentator. Very enthusiastic and very knowledgeable, of course. Well, she wouldn't be at Oxford if she wasn't, I suppose. And she's been doing a talk about this and giving the opposite point of view, that we don't have to wait 10,000 to 100,000 years for it to explode, but in fact, a few decades. So a lot of scientists think it's going to go. She's going to blow any time, and we're going to see it. And that's yeah, it'll be very bright. Bright as the full moon. It's going to be as bright, it'll be visible in the day. I reckon, once it goes supernova. Anyway, when the day comes, it'll be astonishing. The supernova's first harbinger, or signal, will be subtle but unmistakable. A flood of ghostly neutrinos emitted during, you can't see neutrinos, of course, emitted during the star's collapse that would wash over the Earth, lighting up detectors from around the globe. Scientists will be doing cartwheels of joy. Shortly thereafter, as high-energy photons burrowed out from the dense expanding cloud of stellar debris, the real fireworks will begin. What we would see is Betelgeuse getting really bright, like 10,000 to 100,000 times brighter than normal on a time scale of a week, says this guy Goldsberg. Depending on exactly how powerful the explosion turns out to be, the supernova could become perhaps 1/4 or half as bright as the full moon. Sorry, I exaggerated. Concentrated, but in a single point of light, which makes it very bright. If sufficiently luminous to be visible during the day and to cast dark shadows at night. There you go. So it's going to be quite a sight. And the spectacle would linger longer enough for everyone to see. It stays really bright for a really long time. I mean, long for a news cycle, short for a human lifetime, infinitely short for a star's life. So a matter of years. Anyway, conveniently, Betelgeuse is far enough away that we won't suffer any harmful effects. But humanity's long history of supernova observations makes it clear that the event would still have consequences. The sky would change so dramatically and it would be so visible to everyone that it would really cause a huge reaction around the world. More of those people like in Close Encounters of the Third Kind, with signs, it's the end, but this time the end of the world, things like that. Anyway, it's going to be quite a sight if it does explode soon. Now, I did tell you about fleeting stars. Remember Zeta Ophiuchi, also known as Psyche Ophiuchus, the middle star, got ding, ding, ding like that, the top one, right? Well, this is, have a look at this. Researchers have found the fastest stars ever to escape the Milky Way, seemingly as a result of another star exploding. Now, this is what I was talking about, type 1 supernova, where one expels the other. Okay, so the researchers identified 2 runaway stars travelling at staggering velocities. J235 is screamed through the Milky Way at 6 million kilometres per hour. 6 million kilometres per hour. While star 927 clocked in at 8.2 million kilometres an hour. Now, on its way out. In total, the research team led by Harvard astrophysicist Karim Badri identified 6 new runaway stars in our galaxy after studying data from ESA's Gaia survey. And they're all the result, they reckon, of a type 1 supernova. And they should allow, that'll be very interesting to study. The 4 stars being pushed by explosions are what are known as hypervelocity stars, which researchers suggest they were accelerated by a type 1 supernova which occurred in a binary system, which I explained earlier. So now there's my favourite runaway star, the one I showed you earlier, Zeta Ophiuchi. And its speed is 108,000 kilometres an hour, which is not even cruise speed compared to the others. So that's slow. And look, that's with the Spitzer telescope in the infrared, and look at the beautiful bow wave in front of that star caused by the pressure of its journey through space. What's that? No, I don't think so. No. Well, the star's not travelling anywhere near relativistic speed. Yeah, it's not per second, Dallas. Yeah, so it's per hour. So, but these, they're almost 1% of C. At 8 million kilometres an hour, I mean, 10 million would be 1% of C. Sorry? That's incredible. Boy, I wonder if they've got planets around. I mean, if they did have, they'd have disintegrated in the initial explosion, I suppose. But on the way through space, they can pick up all sorts of things at that speed. Sorry? I don't know which ones they are. There are only 6 they've identified, but anyway, we're near the end here. So, bizarre object hotter than the sun is orbiting a distant star, breakneck speed. There's always these breakneck speeds. This is an illustration of it. It's a brown dwarf, and apparently 1,400 light years from Earth at a temperature that it's not supposed to have, hot enough for molecules in the atmosphere to fall apart into component atoms. It's also several thousand degrees hotter than our sun, and yet it's not a sun. I mean, it is a sun, but it's a failed sun, a brown dwarf. It should be impossible, but the researchers discovered that the object got an assist from the star it orbits. It is extremely close to its sun, an ultra-hot white dwarf, so close that its year lasts 2.3 hours. So it takes 2.3. Yeah. So the proximity means that it's tidally locked, like the moon is with the Earth, but this is it's one side only, with one side forever facing its star, so it's not rotating. Because of this, the brown dwarf is only superheated on one side. Even though its day side temperature reaches 13,000 Fahrenheit, its night side is a balmy 1,900 to 4,900 Fahrenheit. That's the most extreme temperature differential astronomers have measured on any substellar object. But these conditions won't last long. As its molecules continue to fall apart, the brown dwarf is being evaporated, as it shows you at the top there, by its host star. So it's cooking it away to nothing. Yeah, and remember, white dwarfs are not actually generating. They're actually the Walking Dead. The white dwarf, I was amazed to find this. I didn't realise. White dwarf stars, the energy from a white dwarf, which can reach 100,000 degrees, the temperature, is residual energy from the supernova from which it formed. So it's actually just letting stuff go. It's not actually creating new energy. If you know what I mean? There's nothing going on. And so it'll be the size of the Earth, super dense, and producing this light. There is light and heat, but eventually that'll dissipate and it'll just become a black dwarf. Yeah. Eventually. Billion years later. Curiosity Move, I put that in there because I just love that picture. And it reminds me, look at the stones. You can tell water's gone past. Look at the layers and the sedimentary and the blasting by the wind. It's just exciting stuff. What a fascinating place to explore if you're an astronaut. That would be brilliant. I'd like to do a sci-fi movie on that. Maybe they'll find things there. A massive kilonova explosion. Now, do you know what that is? When 2 neutron stars collide and eventually smash into each other, that's called a kilonova. So, a team of astronauts have found a huge gamma ray burst. GRBs are gamma ray bursts, which can only come from a collision of 2 neutron stars. This is the second brightest GRB recorded in all time, and it was discovered on March the 7th, 2023. And I just discovered, I looked at it and thought, March 7th, 2023. Anyway, sorry, the years are there. By NASA's Fermi Gamma Ray Space Telescope. It lasted for 34 seconds. Using a powerful vision of the Webb, the team spotted several galaxies around the kilonova. The galaxy that they found lies 8.3 million light years from Earth. So this is inside a galaxy 8.3 million light years from Earth. As well as being blasting out long-duration GRBs, kilonovas are believed to be the sites at which the universe's heaviest elements are formed, including gold, platinum, and uranium. So if you want to go prospecting, that's the place to go. I know. But all this stuff is here because of leftover from the other stars, all the elements. Airbus, a company, is developing a system to extract oxygen and metal from the lunar soil. Those Artemis missions, when they eventually get down there, that's what they'll do. They'll use these different methods to get, and so they'll become self-sufficient. Because you can make things out of metal, you can construct things, and you've got oxygen. So you can create a livable environment. ROXY, it's called, regolith to oxygen and metals conversion. So they've worked out a system for doing that. There's another one called MOXIE, but I didn't get that. It's on the Perseverance rover, but I don't know what that actually means. I must look that up. So the metals they get from the soil created can be used in processes like making tools, containers, useful objects for the moon itself, rather than bring them up from Earth, which is a tremendous saving of cost. It dovetails nicely with the efforts to bring 3D printing technologies to the moon, and several other companies are rushing to carry out these efforts. So there you go. So what an exciting thing. So I can see, 10 years from now, we might have a colony on the moon. Roxy's process is relatively environmentally friendly compared to existing metal making methods used on Earth. They've got an emission-free process for creating it, which I don't understand. I don't understand any chemistry, so I can't explain that. This is the surprise image. What is it? No? This will shock you. I looked at that. I had no way of knowing what the hell that was. And I've never seen it. But it's by James Webb through its infrared or near cam. So, infrared wavelengths, seeing through the dust. You're looking at Roa Phyke. Yeah, so you know that part of Roa Phyke, you've got the dark streamers. One of them next to Roa Phyke, beneath it, I think, above it, has got a big V shape. That's what that is. So I could not believe that. You can tell that the giveaway with the James Webb is the star spikes, because they're unique to the James Webb, the way they look. They always have those little double lines, which I think is rather annoying. But anyway, all those stars in that picture are no bigger than the sun, except for this guy down here, which has blown all this material away and created a hollow in it. And it's called S1. I don't know, I tried to look it up and I couldn't find S1. And that brings us to something for you, Mark. I thought I'd put this in. Lego to roll out a Mars Perseverance rover on August the 1st. It's already happened. Anyway, I forget the cost. I think it's down there. $99.99 US dollars. So you can build your own rover. Knowing how we like technical things, it's rather cool. Yeah, the little, what's it called? What's that helicopter called again? No, the helicopter's called Ingenuity. Oh, it's written there, sorry. I forgot I had it there. But I cobbled this together for you, Mark, because I know you like to construct things. And finally, in God's kitchen. Oh, I love it. Something tells me this thing is only half baked, and it's the Earth. Isn't it wonderful? And look at the earthquake save 50 cents. Oh, Gary Larson just cracks me up. Every one of his cartoons, I just think, and the way he looks at it, it's only half baked. It explains everything about the human race, doesn't it? I just love that. It's one of my favourites. Anyway, thank you, folks. That's all the latest news. So, oh dear. Anyway, so that didn't take long. Thank goodness.